Hello my dear students, this is P. Venkateshwarlu, PG to Physics. In previous video, we have to discuss about types of fluid flow, that is streamline flow, laminar flow, turbulent flow. Okay, understand? In this video, we have to discuss about very important theorem, that is Bernoulli's theorem. Bernoulli's theorem. Yes. Bernoullis theorem. Okay, which theorem, my dear children? Bernoulli's theorem. Okay, so coming to statement of this Bernoulli's theorem. Bernoulli's theorem is based on the conservation of law of energy. Okay, so this Bernoulli's theorem is based on the conservation of law of energy. Means based on conservation of law of conservation of energy. Bernoulli's theorem is based on the law of conservation of energy. So what is law of conservation of energy? Yes, energy neither be created nor be destroyed is called law of conservation of energy. Law of conservation of energy. So yes, Bernoulli's theorem is based on the conservation of energy and is applied to ideal fluid. Okay, so it is applied to ideal fluid. Okay, see my children. So what is ideal fluid? Okay, so ideal fluid is a fluid which have no viscous means non-viscous fluid. Means non-viscous means there is no friction between the layers of the fluid. Okay, so and incompressible. Okay, ideal fluid means what? Non-viscous and incompressible. Okay, a fluid is said to be ideal fluid which have non-viscous and incompressible fluid is called ideal fluid. Okay, ideal fluid. Understand my children? So this is based on the law of conservation of energy. It is applicable for only ideal fluid. Okay, so coming to statement of Bernoulli's theorem. Statement of this Bernoulli theorem. Okay, so coming to statement, the sum of the pressure energy per unit volume, kinetic energy per unit volume, and potential energy per unit volume of an incompressible non-viscous fluid in a streamline flow, irrotational flow remains constant at every cross section throughout the liquid flow. Okay, once again my children, statement, listen carefully. Okay, it states that, means Bernoulli's theorem states that the sum of the pressure energy per unit volume, kinetic energy per unit volume, and potential energy per unit volume of an incompressible non-viscous fluid in a streamline irrotational flow remains constant at every cross section throughout the liquid flow is called this Bernoulli's theorem. So according to the statement, we have to write the equation is pressure energy per unit volume, kinetic energy per unit volume, potential energy per unit volume is equal to constant. Understand my children? So this P plus 1 by 2 rho V square plus rho GH is equal to constant. Okay, rho GH is equal to constant. Once again, my children, what is the statement? Yes, Bernoulli's theorem states that the sum of the pressure energy, kinetic energy per unit volume and potential energy per unit volume of an incompressible non-viscous fluid in a streamlined irrotational flow remains constant at every cross section throughout the liquid flow. Here we can use the term irrotational. Okay, irrotational means what, my children? Irrotational. Irrotational flow means so when liquid flows in a particular canal or any obstacle, the liquid path is curled. Okay, so like turbulent flow like this. In this case, the resultant speed or the resultant of fluid velocity is zero. The resultant speed of the fluid is zero. We can say irrotational flow. My children. Understand, my children? Coming to proof, my children. Okay, consider a pipe. Yes, my children. Consider a pipe. So this is pipe. Consider 2 points A and B. Consider point A and B. The pipe, the height from the earth surface is H1, and another end is H2. Okay, understand? Area of cross section is A1. And here area of cross section is A2. Okay, understand? Pressure is P1. Here in this direction pressure acting opposite. Understand? That is P2. Because here P2 is negative. Okay, understand? Pressure entering into this opening P1. Here the pressure acting opposite. In this way, pressure acting, we have to take pressure is negative. Okay, understand? So then velocity V1 is the velocity. Here the fluid out V2, velocity is V2. Understand, my children? So consider a pipe. Okay, so it is not uniform cross section area, means different cross section area. Okay, in which our ideal fluid can flow. So what is an ideal fluid, my children? A fluid is non-viscous fluid and incompressible fluid and steady state flow. This type of fluid is called ideal fluid. Non-viscous means there is no friction between the layers of fluid. Incompressible, so there is no decreasing or increasing the volume after the application of external force. Okay, so steady state flow means at every point the flow is same direction and same velocity. This type of flow we can say steady state flow. These are a fluid contain these parameters. We can say that fluid is called ideal fluid. Okay, so consider a container or consider a pipe, okay, which is non-uniform cross section area. So height from point A is H1, height from point B is H2. So from left side, P1 is pressure, V1 is velocity, A1 is area. Okay, A1 is area, this is A1. Okay, madam, A1 is area. Okay, here A2 is area. And P1 is pressure, V1 is velocity, A1 is area of the left cross section and right cross section. all we can get 2. Okay, understand my children? See here what happened. So we have to find the distance. Okay, first we have to find the distance. Distance traveled by a fluid. Distance traveled by a fluid in 1 second. 1 second. 1 second. Understand? From left and from right at point A. At point A. Okay, see here how much distance. Okay, suppose the fluid starts from here. The fluid displaces from this. Okay, understand? That is denoted delta x. Okay, delta x. So here the fluid moves delta x distance. Okay, how we can find delta x distance? Okay, per unit time. We know that delta x is the distance can travel by the fluid in left side, which is equal to velocity into time, because t is equal to 1. Delta x is equal to v1. Okay, so delta x is the distance at displacement in which the fluid flow in 1 second. It covers fluid flow in 1 second. Understand? Here delta x2 is the displacement when the fluid is flow out. Okay, so here delta x2, which indicates velocity 2 into time t. Okay, we can get v2. Okay, understand? So at point B, delta x2 is equal to v2 into t, because t is equal to 1. Delta x2 is equal to v2. Okay, remember this matter, children. Remember. Okay, understand? Delta x, the fluid flow, that is equal to v1. Here delta x2 is equal to v2. Delta x2 is equal to v2. Delta x2 is equal to v2 minus 1. Understand? So now, so what is the work done? The amount of work done if the fluid flows from some distance. Understand? Be careful. Okay. So what is the work done, my children? Work done is equal to work done at A. Work done at A. So we know that, my children, work done is equal to force into displacement. Okay, what, my children? Force into displacement. Okay, understand? See here, work done 1 we have to find. Work done 1 means F1 into delta x. F1 into delta x. We know that pressure P1 is equal to F1 by A1. Okay, so then F1 is equal to what, my children? P1 A1. Understand? Rearrange this. Delta x is equal to V1. Okay, rearrange this. W1 is equal to what, Nana? W1 is equal to P1 A1 V1. P1 A1 V1. Understand, my children? Understand? See here, from this what we have to get, my children? Okay, we know that density is equal to mass per unit volume. Okay, understand? So then volume is equal to mass per density. Then volume is equal to area into length, delta x. So then this we have to write A into V, because delta x is equal to V. Okay, understand? So we have to write A1 V1 is equal to m by rho. A1 V1 is equal to m by rho. Understand that, children? It is visible. Yes, once again I will explain. Okay, so we know that, my children, our density is equal to mass per unit volume. So then V is equal to mass per density. Then V is equal to what, Nana? Area into distance. Okay, understand? Area into distance. So area into distance means how much distance? V1, V distance. Okay. So then V is equal to A into V. See here, A into V is equal to M by rho. M by rho or A1, V1 is equal to A2, V2 is equal to M by rho. Where we can get A2, V2, A1, V1, we can get M by rho, my children. M by rho. Understand, my children? Okay, see here, work done, we have to write once again, work done is equal to P1 into A1 P1 is equal to what? A1 P1 is equal to A2 V2 is equal to M by rho. M by rho. Rho is density. Okay, understand, my children? It is equation 1. It is equation 1. Understand, my children? Okay, remember it. Okay, it is lengthy derivation, my children. Be careful. Okay, so what is the equation 1? Work done at point A. At point A, it is denoted W1 is equal to P1 M by rho. Okay, so then work done at point B is equal to W2 is equal to what, Nana? P2 M by rho. P2 M by rho. It is equation 1, it is equation 2. Okay, understand, my children, how it will come? Okay. So here, total work done. What, my children? Total work done. Total work done means delta W is equal to W1 plus W2. Okay, understand? Here you can write it is negative. P2 is negative. P1 M by rho into minus P2 M by rho, because P2 is negative. Because P2 is negative. Okay, because which is acting opposite. Okay, P2, why we have to take negative means pressure acting opposite. Pressure is acting opposite. That's why you have to take P2 value is negative. Understand? So it is equation 3. It is equation 3. Okay, see here we have to find total work done. Okay, so according to work energy theorem, according to what, my children? Work energy theorem. According to work energy theorem, the total work done by the force, which is equal to the sum of the changes in potential energy and kinetic energy. Understand? So what is work energy theorem? Work done is equal to change in kinetic energy in previous derivation, which is work energy power. Okay, in this case both kinetic and potential energies is there. Okay, understand? Both kinetic and potential energy is there. In this case we have to take work done is equal to change in kinetic and potential energy. Kinetic and potential energy means delta W is equal to delta KE plus delta PE. Delta KE plus delta PE. Understand, my children? Delta W is equal to KE. Delta KE means KEF minus KE initial. KE initial means initial plus PEF potential energy final, potential energy initial. Okay, understand, my children? Understand? Remember it, very important one, my children. Okay, so once again you can see this video. Once again you can watch this video. Okay, very important one. Okay, so this is equation 4. Okay, understand, my children? So from equation 3 and equation 4. From equation 3 and equation 4. Okay. So yes. What my children? From equation 3 and equation 4, delta W we have to write P1m by rho minus P2m by rho is equal to say kinetic energy final. So kinetic energy final. First here kinetic energy initial is equal to 1 by 2 mv1 square. Okay. So then kinetic energy final is equal to 1 by 2 mv2 square, mass is same. Okay. And potential energy Pe1 is equal to mgh1. Then Pe2 mgh2. Understand? Kinetic energy we know that. Okay. So kinetic energy of a body gets moving body, or a body said to be having kinetic energy means that having some acceleration, some velocity. Okay, due to motion, a body gets kinetic energy. So potential energy due to configuration, where how much the height, what is the height from the earth surface, based on that potential energy will changes. mgh, we know that formulas. Okay, understand? By using this data, we have to write KEF means what, my children? 1 by 2 m v2 square minus 1 by 2 m v1 square. Okay, plus potential energy final mgh2 minus mgh1. Understand, my children? Understand? Yes. Okay, here m by rho is common. P1 minus P2 is equal to m by rho is equal to, yes, 1 by 2 m v2 square minus 1 by 2 m v1 square plus mg h2 minus mg h1. Okay, so m by rho we can send left side. Right side, P1 minus P2 is equal to each value we can multiply with rho by m. Okay, means 1 by 2 mv square minus 1 by 2 mv1 square into m by rho by m. Plus mg h2 minus mg h1 into rho by m. Understand? So in this case P1 minus P2, so we can get m is common based on that. Okay, so 1 by 2 m v2 square into rho by m gets cancelled, minus 1 by 2 m v1 square into rho by m gets cancelled, plus mgh2 into rho by m gets cancelled, minus mgh1 into rho by m gets cancelled. Okay, m gets cancelled. Okay, rearrange this. P1 minus P2 is equal to, okay, 1 by 2 rho v2 square minus 1 by 2 rho v1 square. Okay, plus rho gh2 minus rho gh1. Okay, rearrange this. All mgh1 1 by 2 rho v1 square we can send left side. All twos we can send right side. P1 plus 1 by 2 rho v1 square plus rho gh1 is equal to P2 plus 1 by 2 rho v2 square plus rho gh2. Okay, understand? This we can say what, Nana? P1 plus 1 by 2 rho V1 square plus P2 plus rho GH1 is equal to P2 plus 1 by 2 rho V2 square plus rho GH2 plus and so on like that. Okay, this we can say P1 plus P plus 1 by 2 rho V square plus rho GH is equal to constant. Okay, my children, this is proof, my children. Okay, so this is the proof for what Bernoulli's theorem. Okay, understand, my children? Be careful, my children. Okay, once again you can repeat this video. Okay, so if you want, I will explain one more time. Okay, no need to afraid, my children. Yes, this Bernoulli's theorem having some limitations. Limitations. Okay. Okay, this Bernoulli's theorem having some limitations. This Bernoulli's theorem is applicable for zero viscous or non-viscous fluid. Okay, understand non-viscous. Non-viscous means there is no friction between the layers of fluid. Okay, there is no friction between layers of fluid, and this Bernoulli's theorem is applicable must for incompressible, must be the fluid is must be incompressible means so whenever external force is applied on the fluid, there is no change in volume of the fluid. Okay, understand, there is no change in the volume. Okay, the entire volume will not change. Okay, next, third one, it is applicable for only streamline flow. It is applicable for streamline flow. Streamline flow. Okay, understand? So these are the limitations. Okay, the limitations of Bernoulli's theorem is applicable for zero viscous or non-viscous fluid. Okay, the fluid must be incompressible, and it is Bernoulli's theorem is applicable for streamline flow. Okay, my dear children.